Okay, so this right here is going to be the 2024 um, calculus exam. They were just released today, and this is question one. Now the scoring guidelines have not been released as far as I know, so hopefully these are okay, and I'll try and give the best response as I can, and maybe go over what I think the scoring guidelines might want to see. Okay, but it looks like we have a table here, and so here's question one. The temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, where c of t is measured in degrees Celsius. For 0 to 12, t equals 0 to 12, selected values of c of t are given in the table shown. Approximate c prime of 5 using the average rate of change of c over the interval from 3 to 7. Show the work that leads to your answer and include units of measurement. Okay, so we're just going to approximate c prime 5 using the average rate of change from 3 to 7. So a lot of the times they like to see that you write the quotient difference. So that would be c of 7 minus c of 3 over 7 minus 3. That right there, I'm not sure how many points this is going to be out of, but that might be enough to get you one. But in any case, we're given c of 7, so c of 7 is 69, and then we're given c of 3, which is 85. So, and then that's going to be over 7 minus 3. Um, uh, do some calculations there. That's negative 16 divided by 4, which is negative 4, and then show the work that leads to your answer and include units of measurement. So because we are approximating the derivative of c, that would be degrees Celsius over time. So this would be negative 4 degrees Celsius, and time is given in minutes. So that would be the appropriate unit of measurement there. Okay. Um, for B, use a left Riemann sum with 3 subintervals indicated in the data in the table to approximate the values of the integral from 0 to 12 of c of t dt. Interpret the meaning of 1/12 of the integral from 0 to 12 of c of t dt in the context of the problem. So a left Riemann sum with the 3 intervals given here. So this right here would be the first interval, and then we would have our second interval right here, and then our third interval right here. Okay, so using a left Riemann sum, so we'll say this. So we'll say that the integral from 0 to 12 of c of t dt, now we are using a left Riemann sum to approximate, so this should be approximated as, for the first interval, the length of that interval would be 3 minus 0, and then we're going to multiply this by 100. So that would be our first rectangle right there over our first interval, and then we're going to have we're going to have the interval from 7 to 3. We're going to multiply that by 85, again using the left side of this interval. And then we're going to have our next interval, which would be from 12 to 7. And using the left side of that interval, that'd be 69. Okay. So this right here would be 300. Okay. So 7 minus 3. So 7 minus 3. This is a calculator problem, by the way. So 7 minus 3. And multiply that by 85. That's going to give you 340. And then 12 minus 7 is going to be 5. And then we're going to multiply that by 69. And that's 345. And you add all of that up together. And I have 985 as the approximate to our integral right here. Interpret the meaning of this expression. So the expression of 1/12 of our integral. So the meaning of that expression, so 1 over 12 times by the integral from 0 to 12 of c of t dt, this is just the formula for the average value, and what is the average value of C of t, and what is C of t? C of t is the temperature in degrees Celsius of the coffee in the cup. Um, so this would be the average temperature. So the average this is the average temperature in the cup. Let's say the average temperature. Let's be specific. The average temperature in degrees Celsius. In degrees Celsius. Okay. Uh, in the cup uh, of the coffee, I guess I should say. So of the coffee of the right. That's what we want to say, right? Yeah. So of the coffee, um, from let's not forget the interval from t equals 0 to t equals 12 seconds. Okay, so I would make sure that you include your measurements here because you're trying to interpret the meaning in the context of the problem. So this right here would be the average temperature in degrees Celsius of the coffee from t equals 0 to t equals 12 seconds right there. So I think that would get you all the points that you need for part B. And part C, so for 12 to 20, the rate of change of the temperature of coffee is modeled here. So this is the rate of change, the rate at which the temperature is changing of C of t, but over the interval from 12 to 20. So that is beyond our table. So, okay, where C of t is measured. Okay, find the temperature of the coffee at the time t equals 20. Show the setup of your calculations. So we would want to know how the temperature is changing over this interval, and so we can find that by doing the integral from of our rate right here. So if this is our rate, the integral right here would show us the displacement of the degrees over our time interval. So we can integrate c prime of t from 0 to from 12 to 20, but we also have to keep in mind that we also would have to take into consideration what happened before that. And so in this case, we know that the temperature at t equals 12, where we're going to begin our interval right here, it was 55. So simply put, if you want to put this into an equation, so you would say C of 20. That's what we're trying to find. So we're trying to find the temperature at t equals 20. That'd be C of 20. That would be equal to so I would first, I would do the integral from 12 to 20 of c prime of t dt, and then I would add to that 55 because that's what it was. So we're going to integrate from the interval from 12 to 20, but before that the temperature was at 55. Okay, so yeah, you can do this in your calculator. So I have one here. Okay. I'm not sure what I had in here before. Let's see here. I like to put this into my y equals. And then I'll go back to what I had before. So c prime of t is equal to, we have negative 24.55. We have e raised to the 0.01. We have t. Okay, just checking, make sure I have that all written down correctly. Divided by our variable t. Okay, and then so if I go to the math option, I'll go to option number 9 for my integral. This will be from 12 to 20, and then I'll go to my vars functions right here, so it's already in there, dx, and then I'm going to move my cursor, if it will allow me to, plus 55. Let's see how this goes. Okay, and I got 40.329. Okay, so that's going to be equal to 40.329 degrees Celsius. So that right there is the temperature at T equals 20. Okay, so find the temperature. Let me just read through this. Show the setup for your calculations. Okay, yeah, I think that should be good. Alright, and the last part. For the model defined in part C, it can be shown that C double prime of T, so the second derivative is given here, for 12 to 20, determine whether the temperature of the coffee, so the temperature of the coffee is changing at a decreasing rate or at an increasing rate. So this right here, I believe, is stating is C prime increasing or decreasing. So that's what it's asking is C prime. So we can use C double prime to help us find that. So okay, so let me go back to my calculator here. Go to y equals, and let me input this into my C double prime. So um, 0.2455, and then we have e raised to the 0.01. We'd have x right there. Okay. Um, we'd have 100 minus x, close that set, and close that set of parentheses, divided by x squared. Let me probably adjust my window. I'm going to change this to be 12 to 20, since that's the interval we're interested in. And I think I can keep my min and max there. Let's give it a shot, see what we have here. Okay, yeah. So this line that we have here is C double prime. Now this right here is always positive. It's all above the x-axis. So since C double prime is always positive on our given interval right here, then C prime is increasing. Okay, so I would say as such. So C double prime of t is greater than 0 on the interval from 12 to 20. And so C prime, well, I'll answer it just like how they stated it. So, so the temperature of the coffee is changing at an increasing rate. Okay, there's my reason. So my reason is given here. This is my response, and I think that should be good. I guess we'll see when the scoring guidelines comes out, but I think that's what they're looking for. Hopefully you guys found this helpful.